my name is Bakaus. I actually had to change those slides yesterday, which was really hectic because yesterday we just announced our acquisition, which was Zynga actually bought us yesterday. Yeah, all right, thank you. So basically, we're not Dextrose anymore. Those slides were all based on Dextrose branding and all that stuff. So we're not Dextrose anymore. It's really good that I'm not talking about the Aves Engine itself today, because the Aves Engine will likely not be licensable anymore soon. But there's a lot of new cool stuff coming up, and I still want to talk about how to develop fast browser games. So it's still fitting into the direction that we're heading. Yeah, just on the side story, we will be opening a new office in Frankfurt, which is called Zynga Germany. So basically, Zynga is coming to Europe. And that's it. Yeah, that's the whole acquisition. Please read about it on TechCrunch if you want to. So who has seen some video on the Aves Engine? Can you raise hands a bit? Okay, quite a lot. Okay, nice. So with the overwhelming success, and really was an overwhelming success of the Aves Engine prototypes, lots of people actually asked us questions. And questions were like, how do you actually get this stuff done? Yeah. So we were showing stuff like, this is my 27-inch iMac and another screen attached. So we were testing all our prototypes on over full HD resolutions. And people were asking us all this stuff, and I've been trying to go to conferences and talk about it, but there's always not enough time, and you know, I always try to pick up stuff that's really interesting. And you know, also right now is the perfect time to talk about it, because only very recently we got powerful enough hardware to run lots of crazy JavaScript. It depends on whether you go mobile or desktop, obviously. New advanced technologies, CSS3, HTML5, you all know that. Highly optimized rendering engines, V8, Nitro. There's a lot of crazy stuff coming up. From Mozilla as well now. So we figured out early this year that right now is the right time to try to do gaming too. Because gaming is really just a very new field in the web in general, and an untested field. So I still think we were probably the first company who tried to do JavaScript gaming, like a real commercial game engine plugin-less. So additionally, and why wasn't that happening before? Why wasn't that happening? Because, you know, we were figuring, and we were talking to a lot of companies, and we realized there's lots of knowledge needed to build sophisticated games. But many of those game companies, even in Germany, like GameForge, BigPoint, lots of those, started as a hobby. And actual web developers, and I'm one of them, like I'm not a game developer by heart. I've been a web developer for years now. Actual web devs are seldom good game developers, and vice versa. And that's a huge issue. So there's very few around us who know both worlds, and really it's a whole training process, and it's a self-training process for me as well. I've been developing all those techniques who are unique for the web. So that's why I really want to share them. So before digging into the hot sauce, let's first talk a bit about the open web stack. And so HTML5, okay, yeah, everyone loves HTML5, and everyone loves the buzzword. On the other hand, you know, people were talking about this HTML5 game engine coming up, and I was like, well, yeah, it's not really HTML5. Since, you know, HTML5, we're actually not using anything of the HTML5 standard yet, which may be the possible exception of video and audio, which are two things that we are using. But other than that, like all those new nice widgets and controls and new stuff coming up, we're not using any of it, in fact. And we're not even using Canvas for rendering, which I go into detail right away. So it's really not an HTML5 engine, it's an HTML JavaScript CSS engine. It's using all of them, and it might be using HTML5 and a lot of those features in the future, but really it's just using the open web stack. So our pick really is vanilla HTML, CSS for rendering, JavaScript for scripting, client and server, Canvas, but only as a tool and not for rendering, and CSS transforms. And both of them cross-platform. I go into detail about one of them in a bit. So, and then Jquery and Jquery. So I've been a core team member of Jquery for some time now. And it really made sense to use Jquery. And why did it make sense? It made sense because Jquery is a library focused on certain tasks. Therefore, it doesn't get in our way. So we cannot afford a framework that restricts us. That's really the difference between framework and library. So we needed a tool that can ease some tasks for us, like doing selectors. So also what we needed, and that's really important, Jquery comes with great event support. And they did a lot of overhaul recently on event triggering and binding performance. So that's really sweet. Why Jquery UI? Jquery UI really is a different use case because we actually can't use any of the widgets of Jquery. That lets you build richer interactions on top without restrictions. For instance, panning a world map is one of them, since it really requires drag and drop, but it's a different interaction. And the bonus really is a patch by me to support touch events. So basically, by using that mouse interaction widget that supports touch events, the events on mobile browsers like iOS, I have that whole new abstraction that really does it all for me. So that's really good. You also need to think about cross-browser. If you think about Open Web Stack, you do need to think about cross-browser. Does your game engine or your game really does need to be cross-browser? I really find out that usually it's not the case. Because sometimes you just want to do a mobile game and you just want to do it for WebKit browsers. So if your engine is platform specific, there's no real need to care about cross-browser. And obviously the pro is that it's really extreme development speed up. If you do an iPhone game, really try to only do iPhone specific stuff. And sometimes you don't even need to use a library for that. Also, if you start working on the game today, chances are very likely that it will not be out in the upcoming months. So don't worry about today. Pick technologies from the future. Obviously, it's a bit of risky to think about what will happen in the future, but your game really won't be ready tomorrow, and predict wisely. So let's dig into architecture and API design. What do you want to keep in mind? First of all, there's a couple of impossibilities that we discovered. First of all, there's genres that cannot be implemented soon, but pretty soon. For instance, casual 3D games, you all seen Quake 3D in the browser. Simple shooters using WebGL. I think that's fairly possible anytime soon. I think WebGL is not stable enough to do it right now, but please prove me wrong. Also WebGL needs to, there's a lot of work that needs to be done, like nice shaders on top of it, nice libraries on top of it. I know that Google is converting O3D, which is really nice, but it still takes some time. Also, genres that cannot be implemented for many years to come includes next-gen 3D games. Like if you're thinking about doing Final Fantasy 13, like a big-ass console game for the web, that's not, in my opinion, not going to happen anytime soon. Like I've seen really like a lot of games, Unity-based, WebGL-based, that are upcoming from the big browser game companies. And most of them, and this is really unfortunate, most of them look like Quake 10 years ago, which is not the impression that we want to give with our games. Like really, if you think about online gaming, you do want to have something that lives for years to come, because most browsers tend to have a really long lifespan, and most browser games. So if you're looking at popular German titles, they tend to have a lifespan for over 10 years. People keep playing them for 10 years. So if they look bad after 10 years, like which happened to most PlayStation titles, that's not good. If you're looking at Super Mario from 10 years ago, it still looks some kind of nice. It still looks good. So that's just our decision. We made a decision to just do 2D and 2.5D. So what is left? 2D, obviously. Puzzles, adventure, board games, card games, platformers, jump and runs, all that stuff. 2.5D, which is RPGs, strategy, turn-based real-time, simulation, and there's a lot more use cases. And really, what we choose for our prototypes, if you haven't seen it yet, we choose something like that. So this is our newest prototype that we released at E3 earlier this year. And this is kind of a SimCity world community. So you have those houses, and you can walk around and chat with your friends and do crazy stuff. It's all in real time. It's all graphical, and it's all JavaScript, and it's pluginless. So what we really wanted, and that's just a really quick feature list, free mouse panning, obviously, infinite real-time worlds, non-rectangular objects, animated characters, chat bubbles, collision detection, pathfinding, walking into houses, mashups, sound effects, scalable viewports, and obviously MMO readiness, so it scales to thousands of people. And people were asking me, this is all nice, but you know, this kind of sounds like the Duke, right? This is really a huge feature list. And they're right. If you try to develop a classic game engine, that might be the case. But we're aiming for the web. So let's dig into the special sauce now. I know you're all waiting for it, probably. So let's come up with some of the things that we discovered. So first of all, rendering. We had the question of how do I actually render 2,000 objects in less than 50 milliseconds? Because that, if you're looking at scaling viewports to full HD, that's some test case that really might happen. And what we thought, right, was obviously I use Canvas, because Canvas is the hot new thing, and Canvas is sexy, and Canvas is hardware accelerated now. So Canvas is really the way to go. You can load images in Canvas, it's all nice. So here's what happened. We figured out that Canvas, in fact, is a lot slower than everything else. So if you're using a lot of images, Canvas really drags you down, because Canvas image API, unfortunately, is pretty inefficient. Since you always have to initialize the image using the DOM, then you have to wait for it to load until you can actually render it out to the canvas. Which means if you're working with lots of graphics, it's actually way slower than just do DOM. And just have divs all over the place and work with images. So that was frustrating, but you know, I really just wanted to get it fast, so I didn't use Canvas for rendering after all. But that explanation was kind of not enough for many people. They were talking like, okay, I can kind of understand that, but you're still, you know, you're still constructing DOM elements with divs too, and images and whatever. It's not like that it should be a huge difference. So why can it be that much slower? So Canvas-based redrawing, and that's another big point, is also extremely painful. As we had in the talk, if you've attended the talk right before that, they were talking about this a bit. So if you're working with Canvas, what you have to do is, if you have something on the screen happening, and the character, for instance, is moving on the screen and moving its position, what you usually do is simply wipe out the whole screen, the whole frame again, and render it once again, all the stuff that goes on it. And that tends to be really, really slow. If you're looking at operating systems and browsers in general, what browsers do and what operating systems do is partial redrawing. So really what you do have to do, if you want to do a scalable game in Canvas, you have to implement your own partial redrawing algorithm. So what you have to do, you have to analyze the areas that really do change and basically only redraw those areas. And this gets really, really tricky, believe me. Like you have to invest a lot of time into getting this right. And browser vendors were doing it. And you know, if you're working with DOM, the browser vendors are already doing it for you. So I figured it might be really good to just do DOM for our prototypes. So really the basic message I want to give you, don't just go for a feature because it's hot and because it's new. Really try out what you want to do and test, right? Testing is key. Test until you really are confident that it's the right solution for your case. And the right solution for my case was pure vanilla DOM. So next one, delegation. As I mentioned, events is really important for all kinds of stuff we're doing. So what we came up with was really one event to rule them all. That is actually 3 events. One of them is mouse move. Those are the 3 that are most important to control the game. Obviously, you can have keyboard control as well, but for our prototypes, that were the 3 events that we needed. So if you think about clicking on objects, for instance, since it's using event delegation, you obviously you have that, that's a div, and you just put it somewhere on your map. And what happens now? Well, obviously it's using a background graphic, some PNG with alpha transparency, and well, you can click on it. But you can click on the alpha transparency too, which kind of sucks because that's really not the kind of experience that you want. Like if, for instance, if I have another house behind that one and I click into that transparent area, I'm not expecting that house to actually be launched or whatever, opening a pop-up. So this really kind of sucks. So what we came up with was something really creative, and that is click-through maps. This is, well, maybe not that creative, but creative in the web and creative in the way we do it. So the game industry was doing that all over again. They were doing it for years, but I haven't seen this in the web anywhere. So what it means is build up a pixel map for each object that tells us where the transparent pixels are. So if it's transparent, then check behind until you find a valid target. So this is pretty easy because if you do event delegation from the top, you always know, you always control your viewport. So you always know where your stuff is in general, if in your JavaScript. So checking behind is really not that hard, and this fixes our issue, which is really nice. However, there's one issue with that. Building up those pixel maps is amazingly crappy work. It's hard, and you have to automate it somehow. So what we did is we let Canvas do it. So this is what I mentioned when I said I use Canvas as a tool. I'm not using it for rendering, I'm just using it to actually read pixel data of the images. Then we check if our pixel is in fact transparent, and then save this value in a new optimized array, and basically use this whenever we need to check. And it actually scales really well. So it actually works really well. You have to be careful if you want to support IE6, but other than that, it's nice. So that's just one of the tricks. Next one, action surfaces. I was talking about this a bit in our videos, but I'll be going a bit more into detail today, which is really new content. So action surfaces was something we came up. It's basically a droplet of widgets or other objects. So if you look at that TV, right, the black screen basically would be an area where you could drop generic content, for instance, iframes or whatever. So they're transformed to isometric projection in real time using CSS transforms. Since by using CSS transforms, you can transform to isometry on the fly. And it's really way cool. And that's also something, by the way, that could not be possible if you were to use Canvas. Because if you were to use Canvas, obviously you have one surface, and there's no way to actually stick something in between. So if you were to use Canvas for rendering, you would, and you wanted to support action surfaces, you would have to analyze if there's any action surface on the screen, and then generate multiple canvases that lay on top, which is also kind of frustrating. So since we are using the DOM and the whole layering is controlled by the browser, that's really easy. So how do you do it? That's just a code snippet. I might be releasing this somewhere, so you can actually copy it. So those are the CSS transforms needed, and it's really not much. It was really hard to come up with this crap, but and I don't know how the numbers, how I actually got to the numbers, to be honest. But it works. So it's basically, I think I read it up on Wikipedia and figured out how to do the isometric projections. And so if you're using those classes on any of your elements, it basically transforms them to the right angle, to the right isometric projection. And it's really nifty. But of course, if we want to build a game, we want to support Internet Explorer. And even with IE9, and I'm really happy about IE9, by the way, I'm not so happy that it doesn't support CSS transforms, which is kind of bad. But Internet Explorer really, obviously, is, if you want to do a game that scales well, you need to support Internet Explorer. So what do you do? I found out that IE actually owns. So if you dig deep into the source of, dig into the MSDN, you find some interesting stuff. So one thing that many people don't know, who has heard of the matrix filter before? Raise your hands. Okay, there's a couple of them. Nice. So if you dig into the MSN and really deeply, and it's painful, but it's worth it, you find the matrix filter. And the matrix filter really is very, very similar to the matrix function in CSS transforms. Except for two things. There's no translating in the matrix filter. Well, there is, but that's an anecdote, by the way. But if you want to rotate an element, for instance, right, you rotate it, and then the actual box changes its size, obviously. Since if you rotate it, for instance, the box gets higher. And in Internet Explorer, you can actually have it either set to clipping, so we'll actually clip that content and basically not see parts of the box anymore, which is usually not what you want. Only if you use that clipping method, the translating works. If you are not using clipping, and if you use the auto-scaling feature of which luckily Internet Explorer supports, somehow translating is broken. So I don't know why, but this is just something you have to work around. So the matrix is really working very similar to CSS transforms. So what I did, I came up with a plugin called Transform.me, which basically does the following. It parses style sheets and inline styles in IE, tracks them using the IE only on property change, which is really nifty, by the way. And it creates a custom matrix for every function, like rotate, scale, skew, because CSS transforms has all those extra functions as well. Then multiplies our matrices using Sylvester.js, which is really nice, and creates the IE matrix filter in the end with the combined result on the element. And that works amazingly well. For instance, I've once done a cover flow with CSS transforms, which really had a lot of interaction, so you had to actually do it like every millisecond or something like that. And it was working fine on i6, on i5.5 even, which was pretty interesting. So Transform.me really does it all for you. You embed Transform.me like Xcanvas, and you don't have to care about it anymore. It really just works, hopefully. Not in all cases, but in most cases. So that's one of the things. And if you want to check it out, this one is actually open source. So go grab it on GitHub if you want to. So next one, hardware acceleration. One of the key things about browser gaming in JavaScript, and that is something I had to realize the hard way. You know, last year when all the nice browser engines were coming up, like all the nice JavaScript engines, I was like, oh, I never have to care about performance anymore. Nice! But you know, that's only if you work on the desktop. Really, it's so frustrating. Even on netbooks, most of the engines work nicely today. But if you're looking at mobile phones, and we wanted to support mobile phones, and tablets, the story is really interesting, and the story really is different. So if you're working on games that support multiple platforms, you do have to care about performance, and you do have to care about performance a lot. So hardware acceleration really is one big example of how you can improve that. First of all, and that was in the other talk as well, how do you accelerate the open web stack? There's basically two areas that work right now, which is Canvas and 3D CSS transforms. People like the marketing departments of IE9 and things like that tend to say they're hardware accelerating the whole browser, which is simply not true. So there's only certain areas where hardware acceleration is in place. So Canvas and CSS transforms. For Canvas, really good news, you actually don't have to do anything additionally. So that is if you're running one of the following browsers, which is i9, Firefox 4, and Chrome nightly. I don't know if there's any other browser that I forgot. Anyone? Okay, I guess not.
It's only Windows.
Sorry?
It's only Windows for Firefox.
Oh yeah, that's true. Very true. Yeah. So you also have to care about the platform that's running on. But in general, if you are on a platform that is hardware accelerating Canvas, you don't have to care about it anymore. It's just working. For CSS transforms, it's a different case. Because usually you are using 2D CSS transforms. For instance, if you want to rotate an element, you're just using the rotate function, which is basically 2D CSS transforms. But unfortunately, those 2D CSS transforms don't get hardware accelerated. So 3D CSS transforms, on the other hand, are all GPU accelerated on browsers that support them, for instance, Safari. In Chrome, for instance, they just map to the 2D functions, so they won't get accelerated. But if you're using Safari, that should work. So 3D transforms are all accelerated, but on the other hand, I mentioned again, we are just doing 2D gaming, so we don't really need 3D. So what do? It's really easy if you think about it, and the solution is mapping. So you just simply do all 2D animations that you want to do, you map them to 3D animations, but not actually change the layout. You actually transform it to translate 3D 10 pixel, 10 pixel, and simply leave the Z axis. So that's just what you do, and all in all, it just works. So, and bonus, and this is what we're doing a lot too, you can use this for repositioning and animating. So if you're moving a character on the screen, don't actually change left and top, but use translate 3D, and it will be a lot faster on iPhone, on iPad, and on Android. So that's really something worth to consider. Server-side JavaScript. I mentioned before that we're using JavaScript both on the server and on the client. I'm going to check really quickly how my time looks. Okay, I have to go quickly now. So people were asking me this, right? Like the game industry guys at least. JavaScript paid for enough already. Now you want to work with it in the backend, since most of the guys were really C++ guys. So why did we choose JavaScript? And I think it's pretty obvious for many of you, but still, single scripting language per project dramatically speeds up the development. Really, like if you have a single language in your team, that's just insanely awesome and insanely effective. And create portions simply can be reused. So there's a lot of like the isometric functions that we can reuse on the client and server. So JavaScript, and obviously I love JavaScript. I'm really a geek by heart, so JavaScript is awesome. Node.js, I'm going to skip right through this because everyone knows Node.js, I guess. So JavaScript in the browser, JavaScript in Node. Great innovation, obviously, is event-driven. It's non-blocking. And this is a lot of the advantages that why we were using Node.js for the prototypes. IO API is also non-blocking. Blocking versus non-blocking, well, we got that. Modules, ECMAScript, and now really quickly bonus time. If you do animating a lot of stuff, there's a new method in Firefox, Firefox Nightlies at least, which is called Requestanimationframe. It sounds really crazy, but it's actually pretty useful. So usually if you're animating in JavaScript, what you do is you're using intervals and timeouts. And if you're animating 50 people, you're using 50 intervals and timeouts. And chances are that, for instance, every second you're doing 500 of those rendering calculations. But you don't need to because the browser doesn't update in 500 frames per second. So if you're using Requestanimationframe, you're basically doing it through events. You're waiting for an event to fire and then triggering the next event. So the browser is actually controlling how much you can render at a time. So using that interface, actually the browser is simply scaling for you, which is really nice. Mega bonus time, CSS animations. Well, there's CSS Transitions. I think most of you know them already, which just animate from one state to another, support timing easing. CSS Animations are really more effective because you can control them. They can have keyframes and you animate from one certain value to another one, for instance. They have unlimited steps and you can use any CSS. You can also trigger them, like repeat them and start them and stop them. And they're really useful for position animations, opacity animations, color animations, and size animations. They're not useful for a single one, and that is Sprite Animations. So for Sprite Animations, and we were using those a lot, like for instance, if you're animating a walking character, you actually have to do that through Sprite Animations in 2D games. So Sprite Animations you can't actually do because if you try to do Sprite Animations with the keyframing, you define a couple of background position values through keyframes, and then unfortunately, everything between the keyframes gets interpolated, so you see the background image sliding, right? So it's not just jumping from one position to another, like picture, 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 it's actually sliding through it. So that kind of sucks, and that's not the impression that we want. And luckily, this is really, really hot, and this is really, really new. This just went into the specs recently, like I think 2 weeks ago, 3 weeks ago. It's not implemented in any browser yet, which is unfortunate. But really, steps is nice. Steps is a new easing property. It's a new timing function. So basically, what it does, it's not easing at all. It's actually disabling easing. So if set keyframes are in fact behaving like individual frames. So with that, you can actually control it. You can actually control single framing. And I hope we can see some implementation soon. I know there's tickets already. And hopefully, something is coming up. So that's it. I think I'm right on time, almost. I also wanted to mention, follow me on Twitter if you want to see new stuff coming up. And also, I'm here for recruiting as well. So if you're looking for an awesome JavaScript job in Frankfurt, and alongside me and another couple of guys, we're hiring, we're looking for the best JavaScript engineers, and we have lots of exciting opportunities now. Thank you. Are there any questions left? I think I forgot to ask. Yeah, one? The engine? Well, you know, the engine is coming along quite well. We're starting to do the real coding. But as I mentioned, like, unfortunately, we'll never see the day of light for other vendors and other companies because it will stay in Zynga internally to build all the Zynga platform and Zynga gaming experiences. So if you're looking at middleware, you probably have to jump on some competition. Can you move a bit forward? Okay, someone repeated. Which one? Impact.js? Oh yeah, I've seen that one. I've actually talked to the guy behind Impact.js. And I actually wanted to hire him. He wasn't interested. But I love it. Like, I really want to see competition growing. And I think that's the best that can happen right now. I always mention that in my talks before. Like, I want to see competition. I want to see the web major on gaming too. Like, I want to see people jump on it and develop great games, which is really all I'm for. So competition is awesome, and if you want to do a game engine, please do so. Yeah. I think I didn't get the question. Yeah, I wondered about that too. I don't actually have an answer for that. It sounds silly, but you know, I know there's on Q WebKit. I think there's some guys who are experimentally trying to you know, hardware accelerate more than what is available right now, like also the 2D transformations and animations as well. I think it's coming. I think it will eventually come. And
As that will try to pretend the three-dimensional transforms, and it's because of that?
yeah, I guess so. Yeah.
I think it's a legal issue.
Yeah. So I hope it will change soon. Yeah, it's all pretty fresh still. All right. Thanks again.